Hey everyone, Dave here. So I want to carry on with implementing our transfer method here. So let's get into the meat and potatoes here of doing a transfer. So the first thing we're going to want to know are the balances of both accounts. So to do that, let's create a variable from balance equals storage current context. We're going to use the from address as our key, and that should be all we need. Current context again, 2. So now we have those. There is an extension method here that you can run. Actually, one thing I forgot to mention in my previous video that I want to cover quickly here is these extension methods can be a little wonky. So you see here how we've got this owner to script hash as a global variable. What will happen here is when you run this through the .NET compiler or your C# compiler, is it will actually run this code here. So it'll take this and convert this to a byte array and put that into the IL, right? So the DLL never has a call to do this work. This is going to be done, I believe, I'm 99% sure of the compiler. I haven't really dug into the details of it here. And that way, once it is in the DLL embedded as a byte array, the Neo compiler can convert that byte array to its own bytecode here. The fun thing is, if you were to take this and put this, let's just call this owner2, in here, you know, as a C# developer, that's totally fine. We can call it that, even though it complains about my casing. This is going to blow up, right? While this is valid .NET code, and it'll compile to a DLL and the IL be fine, what the VM is going, or the Neo compiler is going to do is going to say, well, I've got this string and then I got to call this method toScriptHash. I don't have an operation called toScriptHash in the VM, so I don't know what to do. So if we build this, it's going to fail. It takes forever, but it will show us an error saying it can't do this here. So this is just one of the limitations of Neo. Yeah. Let's go back to the output here. You will see func only used for read-only fields. I'm sure it's in here somewhere saying it can't call that, but that is why that fails with that extension method. So you are really limited on some of the things you can do within C#, which is why I really recommend to, as you're writing this code, compile often to find out which, you know, innocuous C# statement you used, or so you thought was innocuous, that the VM does not know how to, or the Neon compiler does not know how to translate into a VM operation. That being said, as big integer is one of the operations that it does support. So we can use that. I've also seen different behavior. So instead of using as big integer, you could go new big integer and pass this in. And I have seen some really, really odd behavior or differences between how that works and how the extension method works. I believe that I found the extension method works better, so that's why I'm using that. Sometimes I've had it when I've called new big integer that it returns false or true from a method instead of the integer I'm expecting. Anyways, here. So now what we need to do is update storage. You know what, I'm just gonna grab And we're going to use toBalance here plus the amount. So this is how I was saying that this is basically just acting like a database here. And there we go. We now have a transfer method. And we're good to go, right? Well, no, we've got some security issues with this. The nice thing is the documentation is giving us a little bit of background on things that we should do here. So we've done the from and to address. We've made sure the amount must be greater than 0. Function must return false if the from account balance does not have enough tokens to spend. Well, we never did check that. So here, it's minus amount. Is less than 0. So if we take our from balance and subtract the amount, if that's going to make it less than 0, we can just return false. Yeah, so it does say to return false, not throw an exception. If the method succeeds, it must fire a transfer event. We will get into the transfer events. The function should check whether the from address equals the caller contract hash. So this one and this one here is, I believe it's around whether you're having a contract transfer to another contract. I haven't really seen people doing this yet, right? If the transfer is not processed, the function should return false. I don't think it says that if it's successful, it should return true though, which would be nice to have in this document. Because if we get to this point, the transfer has actually happened, and we should return true. So, oh yeah, and another thing we haven't checked so far is that who's calling this method? Right now, anyone could call this. So I could call this as Bob and say transfer from Joe to Jill this amount without any authentication at all. So probably not what we want. This is fairly easy to do. Check witness. We want to make sure that the person calling this is the person who has the funds. So I'm going to just make this into more of a guard statement here and return false. So if I'm not the from address, this fails. And one thing I want to introduce here too, actually, is logging. There's a few methods in here. There's runtime log and runtime notify. I typically use notify for everything. And I will show you why is, so what this will do is it will generate a message on the blockchain. So whenever the VM runs this, you can see this message here. So NeoPython's good that you can turn on SC events as a debug option to see these. So this can be really handy when you're running your live contract. One of the neat things is that this will take in a param array as well. So we could say from to amount, and it will show all those. You can also use runtime log. But that will not take in a param array, or at least I believe it doesn't. Yeah, it just takes in a message, right? And if you try and concatenate different types, the VM will oftentimes have issues with it, if not always. So that's why this one is really nice, and I just basically use it all the time, even if I don't put in the parameters in here. So you don't have to put this in here. This can help debugging, especially when you're actually running on the blockchain to find out what's going on. You know, we've got the debugger right now we're using, so we don't really need to use this. We can get fairly confident in what we're doing here. Okay, so I don't know why I just tried to start it from there. Okay, we'll load up our AVM here. Come on. Let's just look at storage K. This address has that many. So now we're going to run our transfer method. We're going to take our first address, we're going to take a second address, and we're going to do an amount of 1 token. But remember, because we have 2 decimal places, it's 100. I just realized I'm going to need another address here. I don't know if I have one handy here. Just give me 1 second. I'm going to grab one here. Okay, so I grabbed an address. I just grabbed a random one off NeoTracker here, but doesn't matter because we're running locally. So I'm transferring from this account to this account. I better make sure that this always returns true. Yeah. Let us go and debug this here. So the result was 1, so I'm assuming that is a true here. And let's look at storage here. So you see that my account now, 99900, the recipient account now has the 1 token. So I lost 1, they gained 1. There we go. Transfer completed. We could call balance of, and this would, on this address, that would return 1. This one would return 999. So that's the start of our transfer method. Next video, we will do the transfer event and implement a few more nuances to our transfer method. And then we're technically done, but there'll be more after that. So stay tuned.